Hi, I'm Muskan from Cheenta. Today we'll walk through a concept of binomial distribution. Imagine you are flipping a coin n number of times with probability p of getting ahead. This is a very interesting case. If you throw the dice a large number of times, this will give you a beautiful curve that approaches normal distribution via central limit theorem. This transition shows that the randomness in small scale can result into predictability in large scale. Let's learn this concept through a question from ISI MStat sample paper. In this question, it is given that a competition is taking place with 11 matches to be played, each having 3 distinct outcomes. It can be winning, losing, and draw, or any other possibility. The number of ways one can predict the outcomes of all 11 matches such that exactly 6 of the predictions turn out to be correct. Okay, before we solve this question, let's understand how binomial theorem or binomial distribution can help us. Binomial distribution says that if we have n number of trials, n is given as number of trials, that is number of times we are having the experiment, and p is the probability of success. We assume that there are just 2 possible outcomes. One is considered as success and other as failure. Since p is the probability of success, q is given as probability of failure, and that is equal to 1 minus p. Binomial distribution says that if we want to figure out the probability that we have R success in n number of trials, that is given as probability n is equal to R is equal to NCR p to the power R q to the power n minus R. But from where is this following? Suppose we have n trials written in the space, and out of R we can have, out of these, R is the number of success. Let's say 1, 2, and 3. We can place this number of R in any one of them, that is choosing from n options, 3 places or 4 places or whatever the value of R is. And then we have to place success at that point, that is p, the probability of success. So that will be p times p times p, so on, till the number of R's we have, that is p to the power R. And hence we have the probability of failure q number of times, that is q to the power n minus R, the remaining places. That's how it follows that the probability of n is equal to R is equal to NCR p to the power R q to the power n minus R. In this question, we don't have probability, but the same concept is used here. We have 11 matches, that is n is equal to 11, and 3 distinct outcomes. We have to predict the outcome correctly. So let's say that 1 is correct. Thus, success is predicting the outcome correctly, and the second outcome is predicting the match incorrectly. Since there are 3 distinct outcomes, there is just 1 correct, so that will be 1, and incorrect will be 2. We are not considering probability here because we have to tell the number of outcomes and not the probability. So that will be out of 11 matches, we have to predict 6 correctly, that is n is equal to 11 and R is equal to 6. And in those 6 places, we have to predict it correctly, so that is just 1 way. And for the remaining 5 places, we have 2 different outcomes for incorrect options. It should not be correct, that is just 2 of the possible outcomes will be left. So that will be 11c6 times 2 to the power 5, because 5 places are remaining. That's how we use the concept used in binomial distribution to solve this question. Binomial distribution is a very beautiful example to solve such questions, and maybe we can have further implication or further use in normal distribution as well. In this way, binomial distribution isn't just about flipping the coins. It is recognizing different patterns and chances and seeing how nature beautifully acts.